We are done with all these. This is where we left, right?
Yeah.
The questions. We haven't gone through the question yet, right? Which questions? 7B. 7B, right? Last week I have given you one more worksheet, right? 2D. Yeah. This one. Easy. Any one of you going to be absent next week? No, right? Not going anywhere, right? Okay. I just want to know. I think today someone is going to be absent, so we are going to record this. Okay, let's start. I think I think, yeah, okay. This is where we stop. I was using the other screen, so it won't be reflected here. So section 2C. Section 2C, section 2C. I believe we have done up to 7B. Okay, 7C. 7C, they say explain why the boiling point of ammonia, which is an NH3, is greater than the boiling point of the phosphine. So both ammonia and phosphine, if you look at ammonia and phosphine, ammonia has also have a dipole, right? It is NH, NH, NH. This one is a minus, this is plus, and this is plus, this is plus. But for the phosphine is a dipole attraction because phosphine is not a hydrogen bonding. Remember? Because for the hydrogen bonding to occur, it must be between only 3 types of elements. What are they? Nitrogen, fluorine, and oxygen. Remember? So hydrogen bonding is formed between H and O, H and N, and H and F. That's the only thing. This is a hydrogen bonding. So in this case, only ammonia will form hydrogen bonding. This one will form hydrogen bonding. But for this one, it is going to be yes. Yeah, please come in. We just started. So here in this case, we can say that both molecules are polar. See this? Both molecules are polar. But NH3 contains an H bond, which is a hydrogen bond. Okay. So it is capable of forming hydrogen bond. Which is stronger, right? So hydrogen bond between NH3 molecule is stronger than dipole attraction sorry. Between pH3 molecules. So these are the key points you need to involve. So you need to explain based on two things. Both of them are polar. That's one key point. They will give you about 3 marks for this type of the questions. But NH is hydrogen bond. So stronger. You need to have these keywords in it in your mind. Stronger. You need to mention the hydrogen bonds are stronger. Okay, what type of intermolecular force is present in alkanes, such as methane and ethane? What do you call those forces? Are they polar? Methane, ethane. Are they polar molecule? Can they form polar molecule? Whether they are polar or not, how do you determine? They are difference in electronegativity. That is one thing. Yes, of course, C and H, they have difference in electronegativity. However, their shapes is balanced shapes. Okay, remember for the shape of methane is something like this, so which is balanced. Even though they are polar, within that, because of the balanced shape, this is non-polar. Same thing for methane. So methane and ethane, they are non-polar. They are non-polar. Okay, they are not, yes. How are they non-polar? Because of the shape, because of the balance. When you are like trying to pull things together, then it's like a balance forces are pulling. So that means they cancel each other. Oh yeah, of course, this one is after a while you will get used to them. Yeah, okay, of course, now we learn that, okay, methane and ethane, because ethane, of course, later on when we start learning like ethane is something like this, which we have a C, because it's a C2H6, it is like this. This is ethane. So it's balanced. Okay. No, yes. What's your question? How you're going to determine whether they are polar or not? First of all, you need to look at a particular bond. Remember last week we mentioned about between C and H. If you have only C and H, C is more electronegative than H. So in this case, if you only have C and H, it is polar because this side will be negative, this side will be positive. So we have a dipole, meaning it is polar. Okay, so in this case, this side will be positive. This is going to be positive, 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 and then this is going to be negative. But what happened is all these positive are pulling them in the same direction. I mean, it's in opposite direction with equal forces. So it's like as if like you are trying to pull with 4 string for the same thing, then they cancel each other. So if they cancel each other, Remember last week, not only that they are polar, you must also take care about, you must also look at their shape. If the shapes are balanced structure, they will cancel each other, then they will become non-polar. 2 points. Most of the molecule individually, their bonds are polar because they will form between 2 different atoms. When you have 2 different atoms, they are polar. But the shape will determine whether they will be polar or not. If the shape is balanced shape, then it will not be polar. Okay? Yeah. Yeah, both of them are non-polar. Okay? So it's like here also the same thing. This H, the 3H this side, 3H this side. So it's sort of like cancel each other. Okay? But of course, how I'm going to know that ethane, of course, you will know this ethane as a C2H6 later on. But here, I will just say that yes, it's a C2H6 and then structure will be like this. So both of them are non-polar. If they are non-polar, since both of them are non-polar, what is the force? What is the intermolecular force? Anyone? Non-polar molecule, there is only one type of intermolecular force. 3 types, right? They are called dispersion force, yes. Okay. So since both of them are non-polar, molecule, the only intermolecular force is the dispersion force. Okay, order the following compounds by the strength of their intermolecular force from the strongest to weakest. Yeah. This is what I was talking just now. Okay, whether it's polar or not, first of all, look at the bond. Okay, here we have a C and H bond, right? Okay, of course, you will eventually know what is methane. Then now I'm just trying to say methane is CH4. Methane is CH4. And then ethane is C2H6. So the bond between them is C and H. But if you look at only this is minus, this is plus, this is polar. If you just look at one bond only, it is polar. But the shape makes them to be non-polar because the shape is like this. So they balance each other. They cancel each other. Okay? They cancel each other. So they will become non-polar. Any non-polar molecule, the only intermolecular force is the dispersion force. Okay, so this is how we determine. Now, it will be more obvious in the next questions. So let's look at this. First of all, we have 4 molecules are given. These 2 are the same. These 2 are generally what we call it, both are non-polar. Remember, just this is methane. This one is ethane. So both are non-polar. Okay. Then HCl. If you look at HCl, HCl is polar because Cl is more electronegative. Remember in chapter 1, we learned about this, is more electronegative than H. So HCl is polar. This is D minus, this is D plus. Okay, so this one is polar. How about water? It is polar. But what is so special about this polar for water? Hydrogen bonding, because between O and H, remember just now I mentioned about hydrogen bonding only occur between these 3 pair of bonds. Okay, so in this case, polar plus hydrogen bonding. So which one do you think is going to be the strongest out of the four? Which one? Hydrogen bond won't be the strongest, right? So this is the strongest. So this is going to be strongest. So that is going to be number one. Okay. The next one, compared to non-polar and polar, polar will be stronger, but it will be weaker. So this is going to be number two. HCl will be number two. Okay. Now it comes to the third part. So I'm going to write down that H2O will be what we call it strongest. Because it's a H bond, hydrogen bond. And then afterwards, this is number one. Number two will be HCl, which is a polar. Okay. Now 3 and 4. For 3 and 4, we have a C2H6 and CH4. Which one will be in position 3 and which one will be in position 4? C2H6 will be, remember we mentioned about something in the dispersion force. If you recall, okay, let me try to write this down first. Now, how can you justify that this C2H6 is stronger than CH4? More what? I particularly meant more. Yeah, small force is stronger. But how C2H6 different from CH4? When it compared to non-polar, both of them are non-polar, right? Okay, now let me try to focus this one. So this is non-polar. This one also non-polar. So when you're comparing non-polar, the one with a larger number of electrons, because more number of electrons will make it easier to have a, what we call it dipole, okay? So this one has a larger number of electrons, so it's stronger. So stronger dispersion force. So when it comes to both non-polar, you need to consider this part. Which one has more number of electrons in terms of molecule? So obviously when you have 2C, 2C has more electrons than 1C. All right, questions so far? So always consider this. First of all, think, is there any pole, you classify any molecule into polar and non-polar first. From the polar molecule, identify, is there any hydrogen bonding? Special type. The one with the hydrogen bonding will be the strongest. Okay, then comes to polar. Then look at non-polar. In the non-polar, you try to look at which one will be stronger. The bigger one, or like the one with a larger number of electrons will be stronger than the one with a lesser number of electrons. Make sense? Okay. Is that okay? Sure. Okay, so this is what we have done. Last week, I believe I have given you worksheet. Wait, let me pull this in. This is going to be 2D. Um, hmm? Okay. Okay, the next part, which is also the last part that we are going to look at, is what we call it giant covalent substance. Okay, covalent compound. Covalent compounds are formed between what and what? Non-metals and non-metals. And they form by, all of you have this? Have this, right? I gave you last week, 2D. Have it, okay. So they form between non-metals and non-metal. They form by sharing of electrons between them. So their bond strength also depends on how many electrons do they share. But there is all the covalent substances like H2, water, carbon dioxide, all these things form individual molecule. Okay, individual molecule. So those one with a covalent compound with individual molecules are some normally call what we call it simple molecule. Okay, so those with what we call it simple molecule like carbon dioxide, water, H2, Cl2, HCl, all these are called simple molecule. They exist as an individual, okay, exist as an individual molecule with intermolecular force. So their boiling point, melting point depends on the strength of this intermolecular force. And we have learned that there are 3 types of intermolecular force. That's done. That's for the first part. Then the second part that we are going to look at the same covalent substances, but what we are going to look at is what we call it giant, okay? Why are they called giant? Because they do not exist as a simple individual molecule. They will have a, what we call it interconnected structure, okay? So both diamonds and graphites are completely made up of carbon atoms. So that means they only made up of carbon atoms. They are covalent bondings, but they have a very high melting point and boiling point. I would say that generally diamond it's about melting point of about 3000 degrees Celsius, which is pretty high. Okay, so why is it so? They say that to start the diamond forming process, it's almost like this. These things are general understanding, but these extremes conditions allow these carbon atoms to arrange into a what we call it tetrahedral formation, and that will form like a diamond appearance. Okay, in the absence of such conditions, graphite can be formed. Extreme conditions, graphite can be formed instead of a diamond. So both of them are made up of carbon atoms, but they have a different structure, which means that diamond has a tetrahedral structure and graphite has different structure. We'll talk about those structures slightly later. Then we also know from the points that graphite is used as a crucible for storing those molten steel. So that means it's also have a high melting point and it's also inert. Okay, high melting points and inert. Graphite is also high melting point and inert. What do you mean by inert? When you see this term inert in chemistry, what does it mean? Have you heard of inert gases? No. Helium is also called inert gas. Those like group 18 gases, noble gases are inert. Why are they called inert? Because they are not chemically active. Okay, so inert means not reactive, not reactive. So that means it will not react with most of the compound. Okay, not reactive. Inert means not reactive. So because of this property, we will use this graphite in another application called electrolysis, okay, which we will do it in unit 3. So coming back here, there is one key point that you need to know. They are known as allotropes of carbon. This is a key point. What is allotropes? Allotropes means made up of same element but different structure, arranged in different structure, different shapes, or different arrangement. So anything which is made up of the same thing, but they have the different arrangement, they are called allotropes. Okay, allotropes. Okay. So although both diamonds and graphites are chemically the same, they have entirely different atomic arrangements. Entirely different atomic arrangement. We'll talk about this atomic arrangements later. So they are bonded to each other. So carbon atoms are bonded to each other by strong covalent bonds with different arrangement. They have a different crystal structure. In diamond, okay, so this one is important. In diamond, all 4 valence electrons on each of the carbon atoms are bonded to 4 neighboring carbon atoms by covalent bonds. So which means it's like this. So how does it forms? So one carbon will bonded with 4 carbon atoms in 3 dimensions. And again, it will form another 3 like this. It will be extendedly going on like this. So this particular structure is called tetrahedral structure. Okay, so this is what we call it extremely rigid tetrahedral structure, stable in 3-dimensional network. So it is so they will be extendedly bigger. So they do not have like individual molecule. They will all be interconnected. Okay, so that's why they are called giant structure. It's not individual, like water is just single molecule. That water molecule and another water molecule will not have any bond in between. Then those water molecule is called simple structure because there is no bond between the 2 water molecule other than hydrogen bonding, which is not really a bond, it's just a force. But here, each carbon atom is bonded with another carbon atom. So they are different structures. So that's why they are called giant structure. It has a very giant molecule. So if you look at like one diamond, that one diamond is one molecule of carbon atoms all joined together. Does it make sense? Okay, so that's why they are called giant structure. Another shape for graphite, when you do not have a very high pressure and temperature, it will form layer structure. So that means in this case, each carbon atom is covalently bonded to 3 other neighboring atoms. So when they make it to have it, there is a very unique point that comes out because when you have it, there will be a one free electron because carbon has four electrons. So if it is bonded with 3 carbon atom, you will have this guy, which is extra electrons, will be very loosey. Okay, remember we have a 4 carbon is in group 14, so it has a 4 electrons in the outermost shell. So when it's formed 3 bonds, this guy is what we call it free electron. This one become free electron. Remember, when you have lone pair of electron, it will be attached to the atoms. But if you have only 1 electron, that is what we call it free agent electrons. Later on, you will learn it in unit 3, unit 4. It's called free agents electron. That free agent electrons will become, as the name say, it will be free, coming out. So once it's coming out, because of this property, graphite can conduct electricity because of that electron. It's acting like metal. Okay. These points are important, okay? All carbon atoms are tightly in one layer, are held tightly in one layer, forming 6-member hexagonal ring structure. And this free electron is called delocalized electron. On each carbon atoms move freely within the whole structure. So we have like a sort of like shell layers here. And in between the layer is a weak force of attraction between the layer. So that means the layer can slide over each other very easily. So in this case, the distance between carbon atom within the same layer is shorter than the distance between the 2 layers. So there are 2 different forces exist. The between the layer is weak, so they can actually slide over each other. And then it's also, but those layers are very strong. Do you know where we can find graphite? Sorry? Pencil. Yeah, it's pencil lead. This one is your graphite. Okay, your pencil lead is your graphite. So in terms of this, okay, appearance, diamond is transparent. It is transparent because of that tetrahedral shape structure. Okay, for the physical properties, one thing that we need to do, this is soft substance and also slippery. So normally graphite is used as a solid lubricant in moving parts. Thermal conductivity is not very important. This hardness is important. Electrical conductivity is important. They will always ask this electrical conductivity is due to the free moving delocalized electron. Okay, so this part is important. You should be able to explain that why this can conduct electricity. Okay, so they will say that why graphite can conduct electricity. Graphites are used as an electrode in electrolysis. We need to know about a little bit of application. It is to use to cut through the various hard substance and hard crust. So it's used in drills. So they will actually drill it. It's mainly this one due to, oops, sorry. Okay, due to its infinite tetrahedral structure arrangement, diamond has a highly strong and rigid 3D structure, making the diamond the hardest substance on the earth. Okay, so that is one reason when they ask why is it hard, you should be able to make use of this term. It's infinite tetrahedral structure arrangement. Okay, infinite is not so important. The important is the tetrahedral structure arrangement. Strong and rigid 3D structure. Found in the burst of the dental drills, yes, it's a heat conductivity. It's also good in heat conductivity. It's an excellent heat conductivity. So they can heat up quickly and drill it into the tooth more efficiently. Graphite. We use it as an electrode in the battery. Okay. We will do this very details about lithium ion battery in unit 3. So this one will be in your unit 3. Unit 3, 4, yeah, next year. What is more important is they are able to charging and discharging because it's a rechargeable battery. Remember? Do you know where the lithium ion batteries are? Where? Any rechargeable battery and your Tesla car has a lithium rechargeable battery. Okay, so yeah. So lithium ion rechargeable, this is mainly for rechargeable. So you have to use charging and discharging cycles. It's enabled by this delocalized electron. Graphite that acts as a reversible host for lithium cation. You may not understand what is meant by reversible host. Because we need to understand a little bit about charging, discharging, what happened. But anyway, what we are trying to say is because of this delocalized electrons in graphite, they are able to use in both charging and discharging cycle. Okay. And it's also used as a solid lubricant. The bonding force between the layers in the graphites are weak, so they can easily slip over each other. Okay, so that makes a good candidate for the lubrications and as a pencil. Okay, let's quickly go through this. Okay, which element is found in both diamond and graphite? Of course, carbon, right? With reference to graphite and diamond, which is the better conductor of heat? Do you know why is it better conductor? It's more tightly packed, so they can conduct the heat better. So of course, diamond. Electricity is graphite. Okay, here in this case is heat is not carried by electrons here in this case because amount of the heat that electron can carry is very small. It's by the vibration of the particles here. Yeah. Because if you look at like graphite, in the graphite, the amount of the electrons that you have compared to metal is very small. So it's not like metal conductivity in terms of the heat. Okay, in metals, they have their structure is different from graphite. The electrons are able to move faster in metal than graphite. So in metal, heat is heat is also carried by electron because their metal have a larger number of electrons than graphite. But however, sometimes we do not use metal as the electrode because metals are not chemically inert. So if you use a chemical that metal electrodes in the battery, they will involve in a reaction. So that's why we can't use them. So we have to use graphite. Okay. Which is the hardest naturally occurring substance? Of course, is diamond. Okay, what are the example of application of graphite and diamonds according to their unique physical property? Provide at least 2 examples of each. Diamond can be used as part of the drill, part of the cutting tool. As well as and graphite is an excellent material for battery anode. Anode of rechargeable battery. Okay, I'll talk about I'll explain a little. Yes, sure. I'll explain a little bit about why must be anode, not cathode. Remember, in a battery, look at plus and minus, right? Plus is called in battery, plus is called cathode, actually, the opposite way. Okay, but anyway, rechargeable, it works in both ways. So we have 2 electrodes. You can only use in one because the other must involve what we call it lithium oxide. Lithium oxide is used as the other anode, other electrodes. And only one electrode is used for the graphite. Okay. Anode of rechargeable batteries. Most of the rechargeable batteries, we use this one. As well as solid lubricant. Its property is what we call it. They call it low shear strength. So low shear strength means it's like when you have a 2-layer, if it is easy for them to be able to slide over each other, that is called shear strength. Means shear mean when you shear something. If you have a high shear strength, that means not easy to slide over each other. Low shear strength means easy to slide over each other. Okay, so we call it what we call it low shear strength. Yeah. Okay, the next one. Okay, section 2D. What is the molecular geometry of diamond graphite? You may need to explain a little bit more details. So in diamond, each carbon atom each carbon atom is covalently bonded with four neighboring or four other carbon atoms. So you need to mention about this. In a tetrahedral arrangement, molecular geometry, yeah, forming a rigid giant structure, giant 3D structure. So that is for diamond. In graphite, each carbon atom is bonded with three carbon atoms forming, they call it trigonal planar structure. With layers we don't say off layers with low shear strength. Okay, so key points are like trigonal planar structure is one particular key points, and layers with low shear strength and bonded with three carbon atoms. This one is for other tetrahedral arrangement and rigid giant 3D structure. So these are your key points. Same as what you have it. Yeah. I think question 2 is pretty straightforward. You should be able to do it. One is graphite, one is diamond. Okay, so I'm not going to like particularly going through this two. Then okay, let's look at question number 3. Bonded with three atoms forming trigonal planar structure of layers with low shear strength. Yeah, no. Question 1. Question 2 is it's just kind of like repeated, so you should be able to do, right? What are the main structure similarity between graphite and diamond? So what are the main structural similarity? They are covalent bonds. Yes, they are connected between a strong covalent bond. So it's also like giant structure because each layer will be also like it's a large, forming a very like large crystalline structure. So of course this is trigonal planar. This is trigonal planar, sorry, trigonal planar. This is tetrahedral. In terms of the similarity, main structural similarity is covalent bond. Extensive giant structure, not individual molecule. Yeah. Also sometimes they call it those things as a crystalline structure. Okay, let me explain a little bit about why are they called crystalline structure. You will find that one in chapter 4 when we look ionic compound. Okay, ionic compound, one of the most common ionic compound is your table salt, the salt. So if you look at the salt, if you really pick up a piece of salt and put under the microscope, what do you see? It's a crystal. Yeah, so that kind of a structure, they also have a similar structure. It's extensively connected. It's not individual molecule. Ionic compound do not form molecule. They form what we call it, what are you doing? They form like it's like positive and negative ions all interconnected. So that's why they call it crystalline structure. Okay, which is a better heat conductor, diamond and graphite? Refer to the covalent bonding presence in each of the explained answer. Again, yeah, so in this case, diamond is a better heat conductor. Is a better heat conductor. Because every atom in diamond is tightly bonded with all neighboring atom forming very rigid structure for which make it to be able to transfer heat by vibration efficiently. So it's a conduction. It's a good conduction in the senses, not by the electrons, it's by the vibration of the particles. Yes. Which makes it to be able to transfer heat by vibration effectively. Okay, question? This chapter is a little bit heavy in the theoretical explanation. So make sure that you, when you answer, you have those keywords in it. Okay. Why does the graphite conduct electricity while diamond does not? So we already know about this because of the free electrons, right? So it's due to its free lone pair, not lone pair, it's a free electrons, free mobile electrons. Because each carbon atom in graphite only bonds with 3 other C, leaving 1 electrons from its outermost shell. Free to move within the structure. Yeah, that should be good enough. They say graphite while diamond does not. So you need to mention about why diamond does not. In diamond, this is in graphite, but in diamond, there is no free electron. Yeah, that's just the shortest way of saying that. Yep. I think the subsequent questions are very repeated kind of questions. They say why diamond is the hardest naturally occurring substance because of the structure. I think I've already mentioned about this. It's due to their rigid structure. So question 5, question 6, you can reuse the same concept to answer. Provide an example of application of diamond and explain how diamond physical properties. Again, one of the main application is used as a tools like drilling tools, cutting tools. Okay, this is used as a drilling and cutting tools. Graphite is commonly used as an anode material, which is also the same thing. Okay, it is used as an anode material. How do the physical property add as a good anode material, which is a conductivity? So you can mention about conductivity. And graphite commonly used as a solid lubricant. What physical property does graphite possess that makes a desirable material for its application? Maybe I'll go through this. Okay, remember for graphite, we have a trigonal planar structure. So what is the between the layers of a trigonal planar structure in graphite? Between the layers of trigonal planar structure of graphite, there is only weak dispersion force. So the layers are easy, able to slide over each other with small shear force. You know what is shear force, right? It's like trying to apply the two things in opposite direction at different position. So that makes it to make the object to get sheared. Okay. So three key points here that must involve planar structure, weak dispersion force. So with it's able to slide over each other easily. So these are the three main things. Okay, so officially we are done with all the theory. So we have started looking at covalent compounds. Okay, covalent compounds form between the two more atoms, which are both non-metals, and they form the bond by sharing of electrons. So if they share one electron each from each other, they form one bond. If they bond to each other, they have a double bond, then we have a triple bond. So we look at this, and we also look at their bond strength. Okay, which one is stronger, which one is weaker. How the bond strength is generally because they are atomic size. If they are nearer, then they will have a stronger bond because of their the attractive force with the nucleus. Then we look at intermolecular forces. So in the intermolecular forces, we have three types of intermolecular forces: dispersions, dipole-dipole attractions, and then hydrogen bonding. And then it also depends on their shape. So we also look at their molecular shapes. We have what we call it trigonal, tetrahedral, and then planar structure, or like straight line structure. Okay, then there are relative strengths of bonds. This is what we need to know. Then finally, we talk about today giant molecular structure. Okay. So I'm intending to just quickly go through this end of chapter review, which will help you to. Okay, maybe why don't maybe I'll let you try first. It's only like 10 questions. So can you try the multiple choice questions now? Okay, okay, go and grab water. Okay, I'll give you some time for you to do. You can refer back to your notes. Are you done? Yeah, almost. Okay, maybe let's quite quickly go through. Which of the following is illustrated in a Lewis structure? So what is the main focus of Lewis structure? Is it all the electrons or is it valence proton? Cannot be proton. Valence electrons or electrons in the last two shell. Yeah, see, yeah, valence electrons. Key point is here, it's a valence electron. Which of the following depict the correct Lewis structure for carbon dioxide? So you need to involve the valence electrons. Which one? B, yeah. So it must be B. First of all, carbon dioxide has a double bond in both. So I mean, none of them, the rest are impossible. So only this one, okay? Okay, which of the following description is true regarding these molecules? Notice there may be more than one correct answer. Okay. The longest and the strongest bond between the two carbon atoms is found in molecule A. Shortest and the weak intermediate found in the molecule C. Shortest and then the strongest bond between the two carbon atoms are found in the molecule C. Longest and the weakest bonds. Okay, long and weak. You can have more, you may have more than one correct answer. Okay, single bond, double bond, triple bond. Which one is the shortest? Triple bond is the shortest, nearest, because it's the strongest and shortest. So normally shortest and strongest is triple bond. So that means C is correct. Longest and strongest are not possible. Shortest and weakest are not possible, right? So these are not something that is possible. How about this D? Longest and weakest bond between the two found in A, which is also correct. Okay, because of this, because single bond is the longest and weakest compared to the others. So both answers are correct. Long mean their distance between them is further apart. So it's long. Yeah, it's just from center to center, from nucleus to nucleus, distance is longer. Yeah. Shape of H2S. H2S is the same as sulfur is in the same group as oxygen. So H2S is, yeah, it's a band structure. Are they polar molecule? This is polar, so is A correct? Non-symmetrical, yeah, they are, NH3 is non-symmetrical. Non-symmetrical means only non-symmetrical molecule will be polar. So first one is non-symmetrical polar. Second one is a symmetrical polar. Third one is a symmetrical non-polar. I think it should be, one is polar, non-symmetrical polar. Yeah. So can the polar be a non-symmetrical? Can polar be symmetrical molecule? No. Okay. So it's B. So any polar molecule must be non-symmetrical polar. What is the correct order of the force from weakest to strongest? Covalent bonding, hydrogen bonding, from the weakest to strongest. Dispersion, A, B, C, D, which one? C, dispersion, covalent, right? Covalent bond is weak. Weakest to strongest, D, yes. Covalent bond is the strongest, okay? Is the bond is the strongest one. That's why we have a diamond is the strongest, they have a strongest structure. Which combination of molecule is capable of hydrogen bonding? Is it A, B, C, D? What? A and D. There may be more than one. So A is definitely, because his water has both N and H. This one is H and F, yeah, A and D. Okay. Which of the following molecule interact primarily through dispersion force? Anyone have an answer for 8? B? Yeah, it's only B. This one is a polar. This one is, or this one has a hydrogen bonding. This one has a hydrogen bonding. Okay, this one is a hydrogen bond. This one is a hydrogen bond. This one is polar. So dibo attraction. 9. Between water and methane. A is correct. What? It's incorrect. Here, incorrect. Incorrect. A is correct. A is correct. No. A is correct. So it is looking for incorrect. You know what I mean? B, yeah. It's a good conductor of electricity. Actually, pure water cannot conduct electricity. Okay. But later on, you will find something called self-ionization of water in acid and base chapter. So it will make slightly easier for it to be conducted. The rest are correct. So it's like B. C, B is the only one which is not correct. Diamond, graphites are both composed of same elements, carbon. Choose the most accurate statement below. Yeah, it's D. They have different 3 dimensions resulting different physical properties. Okay, they say Lewis structure of chlorine for oxygen, it will be double bond. So it should be this. It must have 2 pair of electrons here. For chlorine, chlorine has a 1 bond. So you must have 3 pairs of electrons here. And nitrogen is triple bond. So you have 1 pair of one lone pair. The number of lone pairs are different, right? Okay, look at this. Oxygen is it has a 6 electrons in the outermost shell, right? So you need to add 2 electrons. So you need 2 bonds. Okay, chlorine has a 7 electrons. So you need 1 electrons to be added. So you need 1 bond. Nitrogen is 5 electrons in the outermost shell. So you need to add 3 bonds, 3 electrons. So you need triple bond. Okay. Hi, Howard. Hello. Hi, Howard. Are you okay? Tiring? School day? No, it's holiday already. No, not yet. For you, yeah. That's what people say. Okay, so what do you call it? Independent school or private school, you pay more, but you get less. You have less weeks. Okay. Huh? Don't say that. No, I'm saying that. Huh? It's just that why always 9 weeks, not 10 weeks. Yeah, you have some other things more. Okay, right. VSEPR theory, valence shell electron propulsion. So draw the geometrical shape. Ammonia is because ammonia has a lone pair, so you need to consider the lone pair. And then for us to be able to draw same level as this, and you will have a 1H and 1H. Okay, so it will be like this. So what do you call this one? It's called a trigonal pyramidal, right? For CH4 is like this. You have a 1H here. It's called tetrahedral. Okay, permanent dipole. Oxygen, does it have a permanent dipole? It's a balanced structure, right? Oxygen is like this, double bond with this. You have a like this. So they are balanced. So it's a balance. Same element, they will never form, right? Balance and same element, it's non-dipole. This is not dipole. So partial charge, we do not even have a partial charge because it is a what we call it okay, CCl4, same thing. Cl, 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 and Cl. So you may have a minus, 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 but it is balanced. So this is non-dipole or non-polar, sorry, non-polar. This one also non-polar. H2O is polar. Sorry? How many watts? Is in a balance? They are all balance. They are all pulling in the opposite directions. So isn't it that all the forces are balanced? Remember, if it is a balanced structure, it's non-polar. Remember, we talked about, yeah. Even if you have, for example, like another example of balanced structure is carbon dioxide. So this one is minus, minus, so balance, so non-polar also. Although individually is dipole, there is a dipole, but when you have a balance, the two sides are balanced. So in 3 dimension, this CCl4 is also balanced. Okay. This one is band shape. So band is a non-balance, imbalance, or non-balance. Is it called? Yeah. And another way, maybe we can say balance, or we can also say symmetrical. The other way that we can say balance or symmetrical. This is symmetrical. This is non-symmetrical. So this is polar. And HCl will be non-symmetrical also. Minus and plus. So it's polar. So they have a permanent dipole. They have any polar will have a permanent dipole. I think this one we have already discussed. CH4 or C2H4 have a higher boiling point. So this one has a larger molecule, larger dispersion force. So C2H4 has higher boiling point. Both non-polar, but this one has a higher dispersion force. Higher boiling point, boiling point, short forms. Has a higher dispersion force. Sorry. List the following substance in order of increasing boiling point. This one is hydrogen bonding. This one is dipole. So this one will be, they say in order of increasing boiling points. So it should be a C2H6. It's in the same order. And C2H5OH. Because this is hydrogen bonding. This one is dipole, permanent dipole. This one is dispersion. But you please write down in text, okay? I'm just quickly looking at this. Belows are commonly made of either a pure metal or an alloy, battery anodes, concrete. Group these above ascending metal diamond graphites that could be used instead of okay. That one I think you can do it. This one please try on your own. Let me see whether it's anything which is what's wrong with this? Okay, what is an electron domain? It is a region of a negative charge around an atom, right? So you only have one because it's only one electrons. Because it can only hold maximum, yes, 2 electron in one S shell. Yes, yes. Tell me why is it? It has only one electron in it. Because you have a H and H, you only have a one region. You do not have any other things at the other side. Yeah. Sorry, I can't hear this. No, it's if you are looking at the, for example, like oxygen, it will be different because for oxygen, you have this and then this, so they have five regions. Okay, right. Next week